Okay, let's look at the questions on page 7. Okay, so here you have two different sequences. Are they the same polypeptide? Answer is no, because the sequence, right, shows directionality. It's read from N terminus to C terminus. So the first one, the alanine lysine serine, would be the first molecule on top here. And the second one would be the second molecule, the second peptide here. You can see that the structure is different, right? The center one is the same, but the left-hand side and the right-hand side, the R groups are different. So these are two different tripeptides. Okay, so this question is meant to show, right, even though two different peptides are made of the same amino acids, when the sequence from the N terminus to C terminus is different, they are two different peptides. Okay, next we have this peptide shown to you. Okay, I'm going to start from question 5, right? Circle and label the N and C terminus. Very simple, N and C terminus. Move on to the circling and labeling of the peptide bonds with a P, right? So this is the peptide bond. Remember, the peptide bond is the CO and NH, right? So the entire thing is the peptide bond. You can see that there are 7 peptide bonds. So when there are 7 peptide bonds, then the number of water molecules required to hydrolyze this peptide would be 7, right, to break 7 peptide bonds. And because there are 7 peptide bonds, right, going back to question 1, then straight away we can deduce or conclude that there are 8 amino acids that make up this polypeptide. Besides using the number of peptide bonds, you can also look at the number of alpha carbons, right? So the alpha carbon is the carbon that's bonded to 4 different things, right? So it's quite easy to identify them, right? So this carbon, it has an amino group here, the carboxyl group here, the R group here, and the H is shown like that lah. So it doesn't show you a line with a H, but it's just written like that. So it's quite easy to identify the alpha carbons. So you can see that there are 8 alpha carbons, therefore 8 amino acids. Of course, you can also look at the different R groups, right? You can count 8 R groups, also can. So the different ways to do this question. Okay, move on to question 2, right? The sequence of the amino acids. So here you look at what are the R groups, identify the R groups, and then using the figure 1.3 in the notes to find which amino acid it is, right? So this should be the sequence that you can come up with. Next is to look at the properties of the R groups, right? So you don't have to refer lah, because again, you should be able to look at the R groups and deduce their properties. Okay, so this would be the answer, right? Uncharged, so neutral, only got C and H, so non-polar. This one is charged, so must be polar, and it's negatively charged, meaning it has lost a H+, so it's acidic. This is positively charged, meaning it has gained a H+, so it is basic and certainly polar. Uncharged, so neutral, have a N, have a O, so it's polar. Okay, so you can do for the rest lah. And the overall charge of this polypeptide, right, would be +1, right? There's 1 negative charge here, 2 positive charge here, and then the amino group and the carboxyl group as well, the N and C terminus. So overall, there are 3 positive charges and 2 negative charges, so therefore +1.